Dear student, dear students, today I will explain noble gases. We also called group 18 elements. This chapter is also belongs to second year chemistry. So first of all, in this group, I would like to explain the electronic configuration of noble gases. Here, elements, atomic number, electronic configuration. As we all know, except helium, remaining noble gases have octet structure in their outermost electronic configuration. Helium, the only noble gas which doesn't have 8 electrons in the outermost cell. So helium 2, 1s2, neon 10, 2s2, 2p6 is the outermost electronic configuration, and argon, krypton, xenon, radon. These are all elements have 8 electrons in their outermost cell. So therefore, general electronic configuration of these elements is ns2, np6. Here in this table, I have given the electronic configuration in the shortcut form, not full form. I am using noble gases to write the electronic configuration of each and every noble gas. So here the xenon will form compounds with different elements. So first important topic in this chapter is xenon fluorides. Xenon reacts with fluorine to give xenon fluorides. How many types of, let me explain the types and structures of xenon fluorides. Xenon react with fluorine under different conditions to form 3 fluorides. They are xenon difluoride, XeF2. The oxidation state of xenon is +2, and xenon tetrafluoride, XeF4. The oxidation state is +4, and xenon tetrafluoride, XeF6. Preparations. So preparations are not more important than structures. So here I summarized some of the preparations of xenon fluorides. Xenon and fluoride directly react with each other to give xenon fluorides based on the temperature and pressure. Here, if you take excess of xenon, then we get xenon difluoride. If you take 1:5 the ratio of xenon and fluorine, we get xenon tetrafluoride and 600 degrees temperature and 7 atmosphere pressure. So under the different conditions, xenon directly reacts with fluorine. We get xenon fluorides. Now we are going to understand the chemical properties of xenon fluorides. Reaction with water. Xenon fluoride highly soluble in water, so XeF2 plus H2O gives rise to Xe plus hydrogen fluoride plus oxygen. And xenon tetrafluoride and xenon hexafluoride react violently with water. So when xenon tetrafluoride reacts with water, XeO3, xenon trioxide, is formed. This has explosive nature. And also xenon hexafluoride reacts with water. It also gives xenon trioxide, XeO3. Next, structures of xenon fluorides. First, xenon difluoride. In xenon difluoride, the central atom is xenon. At ground state, it has 5s2, 5p6 valence electronic configuration. So we can also write and shows here 5d0. 5d0 means empty d orbitals are available in the valence cell. In the first excited state, if you give some energy to the xenon, then we get first excited state. So therefore, one electron from 5p transfer to 5D. So therefore, sp3d hybridization is occurred at xenon. When sp3d hybridization is occurred, there are 5 hybrid orbitals are formed around xenon. With the use of two sp3 hybrid orbitals, xenon form sigma bonds with fluorine atoms. Here you can look here, the 3 sp3d hybrid orbitals have paired electrons. So therefore, these sp3d hybrid orbitals with paired electron doesn't participate in bonding, so therefore these electrons are called lone pairs. So the structure of xenon difluoride is linear and it has 3 lone pairs around it. And structure of xenon tetrafluoride. Similarly, xenon has ground state electronic configuration 5s2, 5p6, 5d0. In the second excited state, not first excited state, if you give more energy, we will go into the second excited state. 2 electrons from 5p subcell jumps into 5d subcell. So therefore, sp3d square or d2 hybridization is occurred at xenon. When this hybridization is happened in xenon, how many hybrid orbitals are formed? 6 hybrid orbitals. Among these 6 hybrid orbitals, 4 hybrid orbitals have single electrons, that means unpaired electrons. 2 hybrid orbitals have paired electrons. So these two sp3d square hybrid orbital doesn't participate in bonding because they also have paired electrons. So therefore, xenon use 4 sp3d square hybrid orbitals with 4 fluorine atoms to form sigma bonds. This is the structure of xenon tetrafluoride. It is a square planar. The next one is structure of xenon hexafluoride. Here the ground state is 5s2, 5p6, 5d0 as usual, then the third excited state. If you give some more energy to xenon, then 3 electrons jumps from 5p subcell into 5d subcell. In the third excited state, we have 5s2, 5p3 and 5d3. So sp3 d cubed hybridization is occurred at xenon in third excited state. Therefore, 7 hybrid orbitals are formed. Among these 7 hybrid orbitals, only one hybrid orbital has paired electron. So therefore, that hybrid orbital doesn't participate in bonding. We called it is a lone pair. With the use of the remaining hybrid orbitals, xenon bonds with 7 fluorine atoms to form 6 fluorine atoms to form xenon hexafluoride. The structure of xenon hexafluoride is given here, and also the structure is octahedron. Next topic is xenon oxides. Xenon forms following 2 oxides. One is xenon trioxide and the next one is xenon tetroxide. Xenon trioxide. It is a colorless solid and highly explosive in nature. It is a powerful oxidizing agent. Here the structure of xenon trioxide is given. sp3 hybridization is occurred at xenon and the bond angle is 103 degrees and one lone pair, 6 bonded pairs are there. One lone pair and 6 bonded pairs, 3 sigma bonds and 3 pi bonds. Each and every double bond has 1 sigma and 1 pi bond, so therefore 3 sigma and 3 pi bond in total. Xenon tetroxide, sp3 hybridization, 109 degrees 28 minutes is the bond angle and 4 sigma bonds, 4 pi bonds are present around xenon atom and tetrahedral shape. Next topic is xenon oxyfluorides. When xenon combines with oxygen and fluorine, it forms xenon oxyfluorides. They are xenon oxy difluoride, XeO2F2 and XeO3OF3 and XeOF4. They can be prepared by partial hydrolysis of xenon tetrafluoride and xenon hexafluoride. When xenon tetrafluoride hydrolysis, it will form into it will give xenon XeOF2 and XeFC hydrolysis. On hydrolysis of XeF6, XeOF4 is formed. And the same time XeF6 also H2O, it is also reacts with water to give XeO2F2. So among these reactions we can say the xenon fluorides hydrolysis to give xenon oxyfluorides. So here I will note the important structure of xenon oxy tetrafluoride. Here the hybridization is sp3d square and one lone pair are present, and between xenon and oxygen there is a double bond. Now we are going to understand in this chapter what is the question and answers. This is the first question. I have come across so many question papers, and I will notice this question. I note this question. Fill the following reactions. This is very important question. Answer is also given in this for this question. So that is the end of the chapter.